Hi everyone, today's lesson is on Unit 6, Lessons 7 and 8, and we're going to start looking at the concept of magnitude. So Lesson 7 introduces us to the idea of magnitude, which is really just the concept of knowing how large or small a quantity actually is. So our first objective says students know that positive powers of 10 are very large numbers and negative powers of 10 are very small numbers. So if I had a number like 10 squared or 10 to the fourth power, that would be a very large number. But if I had something like 10 to the negative 3, that would be a very small number. Our second objective says students know that the exponent of an expression provides information about the magnitude of a number. So again, the exponent is really going to help us decide how large or how small a particular value is. So let's look at two facts about magnitude. The first fact says 10 to the nth power. There's always a 10 to the nth that is greater than a number m for any number. The second fact said that there's always a 10 to the negative n that's less than a number m for any number. So, given any number in the world, I can find a value 10 to a power that's larger and smaller than that number m. So as an example, let's let m be the United States national debt. And let's say the debt is equal to $7,073,981,143. Now that number has 10 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so I know that it's smaller than an 11-digit number, like 10 to the 11th power. It's actually smaller than a 10-digit number, because if I round up that 7, I get m is smaller than 10 to the 10th power. So the magnitude just gives me a comparison. If in my second example I said m is equal to 16,755,133,009,522, that has 14 digits. So when I look at it, I know it's going to be less than a number 10 to the 14th power. Because 10 to the 14th power would be 100 trillion. And right now I only have 16 trillion. So I'm able to use 10 to the power of something to give me a relative size of this very, very large number in kind of a simple notation. So no matter what m, we can find the smallest power of 10, which is greater than m. Moving on to Module 1, Lesson 8. Here's where we're going to see kind of a ratio example in comparing quantities, and this is what you're really going to need to focus on your circuit problems for today. So my first objective says students compare and estimate quantities in the form of a single digit times a power of 10. My second objective says students use their knowledge of ratios, fractions, and the laws of exponents to simplify expressions. So let's look at this scenario. It says in 1723, the New York City population was 7,248. And in 1870, the population was 942,292. If I rewrite these values as an approximate 10 to the power, I can say 7,248 is less than 9,999, which is approximately 10,000. So that's 10 to the fourth power. I could do something similar with my second value, which brings me to approximately 10 to the sixth power. 10 to the sixth divided by 10 to the fourth gives me 10 squared, or approximately 100. So that means there's 100 times more people in New York City in 1870 than in 1723.